Welcome everyone to another lecture on programming in C++. Today we are going to talk about member functions and friend functions. In previous class we have talked about classes and object and what are the data members and what is member function. In today's lecture, we are going to talk about member function definitions. That means how we can define member functions. So what are the concepts of inline function? Then we are going to talk about pointers or pointers to a class. And then in detail, we are going to talk about friend function and friend class and their utilities. So let's start. So previously we have seen that how or what is a member function. So today we are going to talk about how member functions can be defined. So there are two different ways to define member functions. One, we can define member function inside the class definition. So this is an example where we have used the example from previous lecture. So we have this box class and we have three data members: length, breadth, and height, and we have defined this particular function void get volume. So the task of this particular void get volume function to return the volume, that is the multiplication of length, breadth, and height. So it will return the uh, volume of this particular box. So that is the function so this function, as this is a member function, so this member function can only manipulate the data inside this class. So here the class definition starts and here the class definition ends, and we have defined this particular function, get volume function, inside the class. There is a way in which we can actually define the functions outside the class. So let's look at that particular definition here. So here we have defined the class outside the class. Class defining means writing the body of the class. So basically, we have the same example from previous slide. So as you can see, class box, we have three public data. We have three public data and one function, and this time we have only written the prototype or function header. So you must include the function header or the definition itself into the class so that it can become a member function of that particular class. So here, as you can see, we have defined the prototype of that class within inside the class definition, and outside we have to use an operator called scope resolution operator. So it looks like this. So uh, two columns one after another, it looks like this. This is our scope resolution operator. So using this particular operator, we can define a particular member function outside the class. So what will be the syntax? The syntax will be same. So this is the return type, this is the function name, and this is the argument list. So the syntax for defining a function outside, or defining a member function rather, outside the class is return type. So this return type will be same as this. Then we have to mention the class from which class this particular function that we are going to write is belonging. Then scope resolution operator. So this is a scope resolution operator, that is this two columns one after another, and then we have to get, or we have to write down the function name. So that is get volume in this particular case, and our argument list. But for this particular example, we don't have any argument, that because argument is void. So then you can just write the body of the function within the braces or within the function block. So let's look at the definition of this particular member function outside the class. So it will be double box, scope resolution operator box, that is defining the class of that particular object, and then get volume, that is the function name. So this is the function name, and argument list. So here in this particular case, the argument list is null, and it will return length multiplied by breadth multiplied by height. So both of them. So this is uh, inside the class. So the definition or the body contains the same thing: return length multiplied by breadth multiplied by height. Whereas this is the function definition outside class. it is also using the same technique. So there is no difference between defining a class inside uh, the class definition or outside the class definition. It is depends on the programmer uh, whether he wants to define everything inside the class or he wants to define the function outside the class. So let's check how we can call or we can use a member function. Uh, so suppose from the previous example, let's create an object of that particular class. To call a particular member function, we need to use a particular object of that class. So the member function was uh, get volume and the class was box. That's why we have to define object of this box class. So we have defined an object of this box class box. So this is the object name and this is the class. So now my box have access to all the public members of this class box. So as we have written get volume function in the public section of this class, we can easily access this particular function using this. So my of box get view. So this will execute or this will command this particular function. So this will execute this particular function. But if some members or some functions that are private inside this class or inside the class, we cannot access them using uh, member function. They are only accessible within the class. That's mean within the class definitions that public members are accessible. So if you want any functions to be accessed from outside the class using an object, you must create that particular function under the public section of your class definition. So let's look at this programming example on classes and objects. So this is a demo of the example that we have shown so far. Includes some extra functions as well, and uh, it showcases the brief description of classes, objects, and as well as member functions. So what we have here, so we have included system.out.println. So this is the code block IDE actually. Here you can find three buttons: build, run, and build and run. So if this build and run actually compiles and executes together, whereas this build function actually compiles and this run function really executes the program. This is a C++ program. So we have included the header file iostream.h, and also we have using this namespace standard for C in and C out, because those scopes will be resolved by this std namespace. So what we have done here, we have applied the data hiding concept, and from our examples from the slide, what we have changed here, we have make them these three data members, we have make them private. So these three data members, length, breadth, and height, are now private. That means we don't want to give access to this data member to outside the class. That means these data members are not accessible from outside the class anyway. Okay, so now we have defined some public functions or from public member functions. So one of them will be the double get volume that we have discussed in the slide. And now we have some other functions that are called setter functions. Setter functions, so two type of functions can be there, and one is the calculative function. So this is a calculative function. That means it calculates something from the data, or it actually gives us some information from the data, whereas two different type of functions are also available there. They are called the setter function and getter function. So setter functions are generally used to set the value of the private data members, and getter functions actually used to get the values from this private data members, or actually getter function is used to get values from this private data member. So we are not using getter function here. We have used a setter function here. So what this setter function does, so they actually set the values of this length. So set length will set the value of length, set breadth will set the value of breadth, and set height will set the value of height. So now we have defined all the functions outside the class. So what we have to do, we have to just follow the syntax. So this is the return type. So we have defined double here. Then the class name. So box is the class name with the scope resolution operator. Then the function name, that is get folio. So as you can see, and the argument list. So here we don't have any argument, so that is a void. So what it was returning? It was returning the volume. So return length multiplied by breadth multiplied by height. Then let's look at all the other functions. So set length is actually defined using this argument double length, and the value of length is being sent to length. And in this particular case, the value of breadth has been set to BRE, and in case of this one, the height is set to HEI. Now, inside the main function, so main is the starting of any program. So inside the main function, we have defined two particular objects, box1 and box2. So what is happening here in the main, in the memory? So a box1 and box2 is being generated, and also length, breadth, and height. I need to also have length, breadth, and height. And also, we have a double variable that will be used to store the volume of the boxes. And now we are trying to set so now we are trying to set the value of the boxes. So box1 dot set length 6.0, box1 dot set breadth 7.0, and box1 dot set length 5.0. So what is happening here when we set the boxes? So this member function has been called to set the function of the boxes. So box1 will be set with 6.0, 7.0, and 5.0. Whereas we have set the box length of box 2 as 12, set the breadth of box 2 as 13.0, and set the height of box 2 as 10.0. So up to this point, we have already used three different member functions. They are the set length, set breadth, and set height. And for individually, for box 1 we have used three of them once, and for box 2 we have used three of them once. Now the interesting thing is that we have used the same function, though the changes that has been made in different functions or different values. That means we have separate sections. For this data members in memory. So for box 1 we have separate sections of length, breadth, and height. For box 2 we have separate sections of length, breadth, and height. So they are not equal. That means for both the objects, two copies of this particular data members has been created so far. So now we are moving to the last part of this particular program, where we try to find the volume of box 1 and then print that particular volume, and try to find out the volume of box 2 and trying to print that particular function. So what we are doing, so volume is equal to box1 dot get volume function. So we are calling this particular member function that is defined here, or rather that is declared here and defined here. So this functions has been called by this box1 object. So what will happen? It will find the volume by multiplying 6 multiplied by 7 say multiplied by 5, because we have used the object of box 1. So whichever object we are going to use for calling these functions, that particular versions of instance variable or member functions are going to be used for the operation. So for this particular case, these values are being used, and when we are using volume is equal to box2 dot get volume, this set of values are being used. So which version of function or which version of the data members are going to be used depends on which object we have used in the program. For this output of this particular program, what will be the output? The output will be volume of box 1, that is 6 multiplied by 7 multiplied by 5. What will be the value that will be replaced by this volume? And in case of this one, it will be box dot get volume, and so it will be the volume of 12, 13, and 10. Now an interesting thing is that in C we used to use a statement like uh, printf, say volume of box 1 percent f comma volume. So if we want to print a variable, what we used to do, we used to specify the format specifier and then all the variables afterwards. But in case of C++, what we have new here, so we can print variables just using redirectional operators. So cout can be used with so many relational operators, and all of them will be printed one after another in a single statement. So what is happening here, we have this string, so we have printed this string on the screen, then we have this particular variable volume. So the value of the volume will be printed here instead of this volume text. So if you enclosed it with this uh, clone. So the print statement will be volume of box 1 is or colon volume. That means it will be treated as a string. But if you just put it uh, like this, it will be considered as a variable, and whatever value this variable may have will be printed on the screen. So the same thing is happening here. And endl is a new statement in case of uh, C++. It actually denotes /n or the new line character. So just execute this particular program. So after executing this particular program, we can see that the volume of box 1 is 210 and the volume of box 2 is 1560. That is the output from this particular program. So from this particular example, we have learned how to create a class, how to create data members, private data members, how to create public member functions, how to define member functions outside the class, how to create objects of that particular class, how to use those member functions, and how to uh, call those member functions to get the computational results. So let's move into the slides. So we have understand get a glimpse of some C++ programming using classes and object. Now take a look at this graph. So this is explaining organization of member function for different objects. So we have two objects there, box 1 and box 2. And what was happening there? So they both, box 1 and box 2, has different set of member functions, this different member variables or data members, or the data members actually known as instance variable. So they have their own copies of their instance variable. And so suppose in this case length is equal to 6.0, breadth is equal to 7.0, height is equal to 5.0. Whereas in case of box 2, length is suppose 12, breadth is also 12 suppose, and height is equal to 10. So these two boxes will have their own copy of the member uh, data members, or instance variables, whereas the functions, they actually share the common code area. So this is called, so this is this particular section called code area or code memory, where the code is being residing. So there is only one copy of the member functions for each object, but we have multiple copies of the instance variable in case of creating an object. So if you create another object, say box 3, so what will happen? It will also get its own copy of length, breadth, and height. But again, these member functions will be shared with this one as well. So it will be shared with this one as well. So the member copies will have only single copy in the memory, whereas every instance for every object, there will be their own copy of instance variable, and that is why objects are called the instance variable. So we generally call objects as an instance variable or instance of a class. Why? Because while creating an object of a particular class, the object gets its own copy of the instance variable in the sense the data member. That's why objects are called instance of a class. Accessing data members using a pointer to a class. So what is that? So suppose you have defined a pointer of a class. uh, we are not dealing with objects now, we are dealing with pointer objects. So we have defined a pointer to a class like this one. So we have a class A here, and inside the class A I have, or there is a function called print that prints inside A and does nothing. So this is a public function. Now what we have done here, we have created a pointer and initialized the object using dynamic memory. So that means and we have created a class type of variable or class type of object using dynamic memory allocation. So a star a is equal to new a. So now this a is a pointer variable to this particular class or pointer object to this particular class. Now how to access this member functions using or whatever member it is, not only the member function, if there is public data member as well, that can also be accessed using this member access arrow operator. So I guess you could remember that in structure in C, this was the same case. If you have declared a pointer to a structure, you can just access the members of that particular structure using the arrow operator. Similar case is here. We can easily access all the members, all the public members, obviously, of this class A using a pointer with an arrow operator. So A arrow print. Also, if we are using this pointer operator to get the actual value or actual object, then we can access the functions using this print function. So as we know that if we have int suppose x is equal to 5 and int pointer p is equal to suppose ampersand of x, then pointer p is actually equivalent to x. That means whatever changes we are going to make in pointer p will be reflected on x. So similar thing is happening here. Uh, so if this is a pointer to an object, so this is the actual object. Star a is actually that particular object. So whenever we have an object, we can use the dot operator. So dot is the another member access operator that can be used to access this members. So let's take a look at the code. So the same code is here. Now let's see what is the output. That means we want to check whether we can actually access this particular statement. So this will be endl. So can we actually access this particular statement using these two statements? So what will happen for this particular print statement? One time inside A will be printed, and for this particular print statement, one time another A will be printed. So let's see the output. So as you can see, the output inside A, inside A. That means for both these operations, we can directly access the member function because the member function is public. So what will happen if you make this member function private? So just make it private. So private members cannot be accessible from anywhere. So what will happen? We cannot actually use these methods or use any of these methods to access this private method, because using an object as well, we cannot access private members of a class. So as you can see, it is not running. It has generated some error. So as you can see, it is showing an error, void a print is private. That means you cannot access that void a using this 14 number operations and also using this particular operation. So this particular operation and this particular operation doesn't have that particular privilege to access this private member. So just make it answer. So this is the output. Okay. So everything's fine. Now let's move into the next topic. Now, this is another concept called inline function. So, I guess you have heard about this term called function override. Function override. So, it is something like context switching in operating system. If you know what is operating system is. Uh, so, what is happening here in this particular case? So, let's just use everything. Use this. So, what is a function overhead? Uh, So whenever we call a particular function, so a process is running or a function is running. Whenever we call a particular function, what is happening? Every state of this particular process. Suppose process one is running. So states of process one will be stored in stack, and the function that we have invoked. So function will be stored in this particular section or in the memory, and then it is going to be executed. So after this function is being executed, again all the stored information from the stack of the process 1 need to be restored. So then again process 1 can run. So this storing up all the details of the current process and then restoring that data or the information of the process so that it can continue execution is called function override. So whenever we call a function, this kind of override is going to happen. Now if we have very small functions, and at that particular situations, if the function override is very high, then the execution time of these functions, so those functions actually doesn't serve the purpose of executing the code faster. They actually makes the execution slow. For that reason, C++ provides us a function, a different kind of function is called inline function. So small functions can be made inline, or rather a single line statement functions. That means a function that has single line or single statements or one or two statements that can be made inline. An inline function, what it does, it actually replicates the body of the function, or actually it replicates the body of the function into the whole program at the compilation time. That means compiler places a copy of the code. That means this code will be placed everywhere wherever it is called. That means if we have cube of 3 is called here, so this particular cube of 3 will be replaced by return s multiplied by s multiplied by s. So this body of this particular function will be replaced with all the occurrences of function calling of this particular function, this particular inline function. So this is done at the compile time. So how can we create a on inline function? So the process is we use the inline keyword before the function definition. So using the inline keyword, we can actually create this inline function, and it is a request to the compiler. That means this is not a command. That means we write a particular function to be inline, and it will become inline. That means it will replace everything on this particular section. That is not going to happen. Uh, because it will, if every functions or large functions can become an inline function, so what will happen, it will increase the size of the code. That means if you have a 10 line of code inside an inline function, you have called that particular function 10 times in your program. So what will happen, that 10 lines will be repeated 10 times. That is 100 line of extra code. So the code will be increased. So that's why only the functions that have one single or two line at most, they can become inline. Also, if you have, or if the function has uh, uh, any operations like say pointer operations, then that function can never be inline functions. So functions defined within a class defined is automatically inline. So we have learned that normal member functions can be defined within the class and outside the class as well. So what is happening? So if a function is being defined within the class, it automatically becomes an inline function, and its compiler decides whether that particular inline request will be accepted or not. So whenever we actually define the function within the class, we are defining a function as an inline function, and whenever we are defining a particular function outside the class, it's a normal member function, not an inline function. So objects as an argument to the function. That means if we have created some objects of a particular class, uh, we can pass those objects into a member function. So it, yeah, and all the rules of any normal argument passing will be applied to argument or objects passed as an argument. So we can pass an argument as a value, we can pass an argument as a reference, we can pass an argument as a pointer as well. So this is a simple example. So we are not going to elaborately discuss this, because the rules and all the facilities of functions on argument passing is applicable for objects as well, and as objects are treated as normal data type in C++. So return type, then the function name, and then class name with the object. Class name with the object. So initially it was type or data type, var1, type var2, something like this, and dot dot dot. But if you want to pass an argument, pass an object as an argument, what you have to mention? You have to mention the class name. That class name is actually the type of that particular object and the object name, and you can use the object as you want inside the body of that particular function. So this is how you can pass an argument, sorry, pass an object as an argument to a particular function. Now we are going into a details to another topic called friend function. So a friend function of a class is defined outside the class scope. So this is interesting. We have learned so far that only the members of the class can access the private members of a particular class. And now here is a concept of friend function that is defined outside the class. That means a friend function is not belonging to that particular class, but has access to all private and protected members of the class. So we know that only the public members are accessible from outside the class, even with using object. That means without using an object, we cannot ever access any members. So forget the private members, we cannot even access the public members without the objects. But here is the solution, that a friend function has access to everything, even though it is not a, a member of that particular class. So what is the prototype, or how we can define a friend function? The friend function for so the prototype for friend function appeared in class definition. So what is that? Friends are not members of any, or not member function. So what we have to do, we have to use this friend keyword before the function declaration, and we have to declare the function inside the class definition. So we have to declare the function inside the class definition. So this will be box 1, I guess. So we are going to define declare the function inside the function definition, but this friend function is not a member function of this particular class. So we have a private member. So as I said earlier, that anything inside the class by default is private. So as we have not specified any access specifier in the for this particular data, it is automatically becoming private. And in the public section we have another data, that is the double length. And then we have a friend function, so void print width. So it will try to print the width of this function, that is a private member, and you not being a member function, it can access actually the private member. So how we can define this particular member function, so or particular friend function? So what we can do, we can just define it as this: void print with box 1, and suppose cout with, obviously box 1 dot with. So this way we are actually accessing the private member, that is with, using an object inside friend function. And you don't have to specify any scope resolution operator or class name, because friend function doesn't belong to a class. So let's check a global friend function like this, like a function that is friend to another class. So this is an example code that will demonstrate the friend function for a class. We have included IOStream, or we have included namespace and all these things. And now we have this particular class. In this particular class, we have this private data member, and we have in the public section, we have a method called set width. So this particular method will set the width of this particular objects of this box class. So using this set width function, we are going to set the function. Now we have this print width function. So this print width function has taken a argument box. So what is happening here? We are trying to send a object as an argument. So this is the example of previous topic, that was object as an argument. So this is how we can send an object as a argument of a class. So friend void print with, this function will be defined. So first of all, let's define this member function set with. So void box scope resolution operator, set width, and then double width. So now width is equal to width. So it is similar to the previous function that we have seen in classes and object example. So that is similar to that. Now print with is not a member function of any class. So as I said, that print with is not a member function. It is just a function friendly to this box class. That's why we have defined it using this friend keyword. So that's why we don't have to specify which class it belongs. We can just directly use that particular function. So print with box. So because print with is a friend of box, it can directly access any member of this class. So that's why this box object can access this with, that is a private member. So this is a private member, this is a private member, and it is easily accessible by this function with. Now for testing this particular code, we have defined a object of box class, say box, and we have set the width of that box class. So what will happen in the memory, sorry so a box object will be created and width will be set to 10. And now we are just using that friend function. So now look at this syntax of using the friend function. We are not even using any object, because there is no point using an object for a particular function that is not a member function. So this friend function is not a member function. That's why we have to send an object, so that this object or the properties of this object can be accessed by this particular function. So in case of member functions, like this, in case of member function, we don't have to specify the object, because we are actually calling the function using the object. So objects is implicitly available in that particular function. But when we are using a friend function, we must send that particular object. For that we want to display the width, because object is not implicitly available for any non-member function. So from this example, if this particular value can print 10, so if the output is width of box is 10, then we can confirm that yes, this friend function, even though it is not a member function of class box, it can access the private member of this particular class. So let's run this particular program. So as you can see, we have this result with a box that is equal to 10. So this is how a friend function works, a normal friend function that actually so it can be considered as a global function. So this is sometimes called global friend function. So it is a friend function that is friend with a particular class. So a single class, uh, this friend function is belongs to or friends or friendly with a single class named box. So this is the example. Now we can see another friend function that is a member function of another class. So just look at this particular example. So here we are going to demonstrate a member function as the function to another class. So a member function, we are going to use a member function, and that is a member function. Sorry, that will be the friend function of another class. And here also look at this particular section. So after IOStream, we have not included the std namespace. So what we have to do here, we have to use, whenever we are going to use cin and cout, we have to use std scope resolution operator. That is the difference when you don't actually include using namespace std in your program. You have to use std with this scope resolution operator to use cout and cin in your program. So what is happening here? So we have a class A, and here we want to display something. So we have this void B, so B function. So B, what it will do? It will print a private member of class B. So as we know that this is a member function of this class, and B is a private member of class B, and we know that only the content or only the member functions of class B can be used. Uh, Member function of class B can be used to access this particular function. So this is called constructor. So constructor will be the next topic for our class. For now, just take it as a thing or as a tool that can actually initialize the object, initialize an variable. So this particular constructor B is going to initialize this particular function or this particular data member B with 0. So that is what happening here. So we are going to discuss about constructors in the next class or next lecture in details. So just for now, just assume that this actually initialize the B value to 0. So what we have done here, so inside the definition of B, we have said friend void, so that is the return type, and we have redeclared the function as friend function to this B class. So we have this so B function with B, and this is by reference. So we are taking a reference to this particular class B class. So we have redefined this B function as a friend function to this particular class B class. So what is happening now? Now this particular function becomes friend function to this particular class. But that doesn't mean that the functions or whatever data or uh, whatever functions or whatever methods are inside this B class are friendly to A. Only this function is friendly to this class, nothing else, no other relationship between them. That means A becomes friends, this function becomes friends to B, that means A is friendly to B. That is not the case here. Or B something, some member function from B becomes the friend of A, that is not the case. Only this particular function of this particular member function of class A becomes friend with this class B. So now if we define this function so B, and now to define this function so B, we have to use the scope resolution operator, and because it is a function of class A, we have to use A as the class name with the scope resolution operator. So what we are going to do, we are going to define that particular function. So void A, because this so B function comes from this is the data member of another class, and we are going to use show B, and we have passed a particular object as a reference. So X is the object of class B. So now we are trying to access this private member. So system.std scope resolution operator cout B scope resolution operator B is equal to, so this is a string, you can write anything here. This is a string, and now we are trying to access the private data. So as so B becomes friendly with this particular statement, that means we have redefined this particular function as friendly to class B. It has now access to the private members of this particular class. So what we have done here, we have defined object of class A, we have defined object of class B, and we have called a dot so B. So this is this time we have because so B is a member function of class A, we have to use an object of class A to call that particular function, and we have set a reference of B. That means this particular X and this particular X actually the same objects. So what is happening here? We are trying to access the private members of class B using a friend function that is a member function of another class, that is class A. So if we run this particular program, what will happen? We can see that B is 0. That means that I said that this particular statement actually initializes the value of B to 0. So that is what happening here, and we can see the value of B this. So if you just initialize it by 10, so I am now initializing this particular B by 10. So what will happen? The output will become, so as you can see, the it becomes 10. That means this particular member function of class A is, as it is friendly to class B, it can access the private members class B. So let's look into the slides again. So let's take another example. So here we have defined a single friend function that is friendly to two different classes. So what we required for this particular class, so whenever we are going to define a friend function like this, so friend void I am friend, so this is our friend function, and this friend function will be friendly to two classes, class A and class B. Now what is happening, we require to pass the objects of both the classes. Now what is happening, class B is not defined when we are trying to define this particular friend function. So if this class B is not defined, so this particular statement is not valid in this particular case. So for that reason, what we can do, we can declare our class early. So this type of declaration called forward declaration. So we can declare the second class as forward declaration. That means we are mentioning to the compiler that yes, there will be a class called class B, and then we have redefined that class B here. So this is the actual definition of the class B, and this is the forward declaration of class B. So this will actually ensure that there will be a class B. So that's why this particular statement will be valid. So what we have to do in case of if we have a single friendly function or single friend function between two classes, we have to define or redefine the friend function in both the cases, and we can define the function as a normal global function as we used to do. So what is happening here? So we have in class A, we have a friend function. So I am friend. So we have sent two objects. One is of class A and another one is class B. And then we have class B, and inside the class B also we have defined another functions or the same function, or we have redefined the same function, friend void I am friend, A and B. So now let's define or actually define the body of the function. So what we are doing here, so void I am friend. So this is the friend function of class A and B, and we have passed the object, and in that particular function we have a single line, or in the body we have single line I am friend to both A and B. So this will be the output of the program. So this is the main function. So int main. So we have created two objects, one of class A, one of class B, and we have called I am friend A, comma B. So this is how a single friend function can be friendly to two or more classes. Just the idea is simple. Just forward declare all the functions, sorry, all the classes that you want to use that particular function except the first one, and then define the friend function with the friend keyword in every class definition, and just globally define the function definition of that particular class. Just moving to the codes now. So this is a friend function between two classes that I was saying. So what we have declared here, we have declared this is called forward declaration. So this is forward declaration, and here we have the same code that was in the slides. So we are running this particular code, and we can see that I am friend to both A and B. So I am friend to both A and B. That means this class A and class B can access this A and B data members. So just put some integer type of data here, make it more realistic that they can actually access this data variables. And suppose I void say A to some value, say int x. So A is equal to x. So we are going to copy this particular function, just paste it here. It will be stated, it will be these so two different functions to set the two different values basically. So we have and now we have this private member in class A and private member in class B. So it is suppose called B and it is suppose called A, and we have created two member functions, one in class A that is to set the value of class A, and inside class B, we are trying to set the value of class B. So now just after creating those objects, we are trying to set those values. A dot set A, suppose 10, and B dot set B, suppose 20. So we have set the values of set and 20. Now here we are going to access I am friend to both A and B, and afterwards what I am going to write here, inside the definition of I am friend, we are going to try to access the values of A and B of us A and B. So just put an end line here, end line, so that line comes after a particular line. So here A is equal to, what we are going to do. So we have already set or change the value of this object. So A becomes A of A1 and B of B1. So what we are trying to do, we are trying to access the values of A1 dot A, that is the private member of A class, and the private member of B class, that is B. So this is equal to A1 dot A and comma B equal to, it will be B1 and then ended. So now if we execute this particular code, what we can see that I am friend of both A and B, then A is equal to 10 and B is equal to 20. So that is the value we have set using this set values. So that means this particular function I am friend is successfully able to access the private members of class B, that is B, and class A, that is A, because this particular single function is friendly to two functions. So this particular friend function is friendly to two functions because they have been defined as a friend in both the function definition. And to be able to do that, we must have to declare the second one or following classes that will have the friend class as forward declaration class. So we can have one function that is friendly to so many classes, but the trick is to forward declare the rest of the classes except the first one, and just declare friend function on every class definition, and then lastly just define the friend function and easily access the private members of this of all the classes at once using a single friend function. But using too much of friend function is not very good programming practice, because that will hamper the concepts of data hiding and encapsulation. So the object oriented concepts basically try to hide the data from unwanted modifications, and friend function actually does that particular trick by unwantedly modifying any data in the program. So too much of friend function is not recommended while writing a C++ program. So there is another concept called friend class. So a class can be friendly to another class, but that doesn't mean the opposite is true. Like suppose you have said A is friendly to B. That doesn't mean that B will become friendly to A. That means A is friendly to B means A can access the private members of B, but that will be not vice versa. That means B cannot access the private member of A at any cost. That means they are not vice versa. That means if I make A as a friendly to B, it cannot become friendly to B can become friendly to A. So a friend function can access private and protected members of other class in which it is declared. So just look at this particular example, then we will move into the code for details. So we have class A. Inside the class A definition, we have said that the class B will be the friend function of this class A. That means class B can access the private member of class A. Just quickly look into the code here. So this is the demonstration to friendly class. So we have this class A. So we have this class A. Inside the class A, we have a private data member int A and a public data member. So again, a constructor is used here to initialize the object. So we are initializing this A by 10. So the friend function, or not this time, not a function, it is a friend class. So we have declared that friend class B, that means B now becomes a friend class of A. So B becomes friend class of A. That doesn't mean the A class can access this members, this data members, because A is not a friend function. So the relation is not vice versa. That means this time only one way friendly. That means B class can access the data members of A class, but A class cannot access the data member of class B. So what we have here in B class, so we have a private member that is not accessible by A class, but private members of B can be accessible by B. So what we have here in public section, we have a show A function. So show A function, so this particular function will show the value of private members or private member of A. That's why we have to put private, sorry, A class object of class A. So we have sent as a reference of object of class A. So what we are doing here, we are trying to print the value of A here. So that is the statement that is trying to print the value of A here. So let's check out the main function quickly. So as you can see, we have declared an object of class A, we have declared an object of class B. So whenever we declare an object of class A, the variable or the value of this variable member data member will become 10, because we have automatically set that as a 10, and we have called b dot show a. So we have passed this particular object into this particular show a function, and as this class B is friendly, so all the members of class B can easily access the private members of class A. So as you can see, that when we are going to execute this particular code, the result will be 10. So that means this particular SOA function can easily access a private member of class A, because we have defined class B as friendly to class A. So this is for today's lecture. In the next class, we are going to look into in details about constructor. And constructor are used to initialize objects. We have seen some examples in today's class. So we are going to explain those examples, how these things are happening and how we can actually initialize the objects. That means how we can initialize the data members of an object using constructors.